Hello, guys. This is Kurt Greschel, the guy who's been writing 10 million emails to you. I'm just going to try to go through the drawings and some video I shot of the frame being made on the shop floor and a CAD model or two to try to help you see how we design the skylight so that you can install it properly and make sure that it'll be watertight. This is the plan view, and you'll have a set of those in the boxes that you'll receive, plus I emailed it. And I've given a code here, X, Z, Z, and a Y, to help you understand which assembly goes where. And you'll pick up that more a little bit later on some different drawings. But in this case, we're concerned with X and Y and these clouds. And you'll see that I have this piece of pie and this one are clouded for the bars to be left out till later. And that's going to allow you to start installing here and then spread the frame to put the horizontal bars in, put it back over, and you kind of sequentially build across. When we do it, we typically go all the way around and just have the last bay be a dead one. But I thought I would give extra just in case it was a little hard to swing everything around. So if you want to, you can just keep building sequential and then drop this one in last. There's only 3 to give you a little bit more flexibility in case there would be a problem assembling it. Be careful as you assemble it because the nature of the geometry will allow the frame to flex and take on slightly different shapes. And if you're not careful, the glass won't fit, and so you want to look very carefully at which bars go where, what's the orientation of the bar, and keep an eye on the dimensions. There's some check numbers to pull from corner to corner that will help you keep the arch the right height and the right width. Don't worry so much about the concrete, keep the frame consistent. You can also check these horizontal bars. They should always be level when you're done. So if you have a level and you put it on and that's level, you're probably doing okay. If they're out of level, you're going to have trouble with the glass. So put this one in, pull a dimension, put this guy on, leaving the bolts loose at the apex so you can wiggle it. Get these bars put in between the 2 arches, and then check to make sure it's level and shim this one up till you get it level. Then repeat as you go around, and it should be pretty easy once you get the hang of it. But the key is take your time, think about it, make sure it's the right part, the right orientation to the right measurement, and then life will go pretty well here. Thanks. Okay, this is the exploded view. And I did that so that you could sort out these little channel clips here. They're all very similar, so look for the code that's written on them and the washer plate code and make sure you do the right combination at each location. Some of them have holes, some are tapped holes. So you're going to want to put the clips on before you do the horizontals so that the bolt can tap to this side. And it's very important to put the right clip in the right place. This would be your typical arch, and I called it Z. You'll need to make 8 of those for each of the skylights. Then where we have the drop-in bars, which was the clouded area I mentioned before, there's 3 of them coded X, and that uses this combination of clips. And then 3 marked Y, and that uses this combination of clips. Well, 8 typical, 3 with variations to make arch X, and 3 with variations to make arch Y. Then you should be able to go back to the plan view and just assemble the arches. So sort your bars. Get your A1s, A2s, 3s, and 4s. Then do your splice plates, the 30, the 29, and the 28. Make sure your holes are good. Splice them together, put all the bolts in, and then put the crossbar clips in and make sure they are all aiming to follow the direction of this bar. And then once those are sub-assembled, you just have to put the parts in the right direction per the plans. There's another page similar to this that has every part code on it, but it gets a little hard to read, and I thought this plus the exploded view made it a little more user friendly. I hope it helps. We don't normally do what you're seeing here. It's just you're a long way from help, so I've tried to make it as clear as I possibly could. I wish you the best of luck. Please watch the whole video. I hope graphically it can get through the language problems we have. Again, good luck. I hope it all goes good, and if you can, send me a picture. We'd like to see it. This is the page that has all the codes for the bars on it. If you look closely on the printed version, you'll be able to read A4, A2, M12, etc. The metal pieces have codes stamped on them or marked with marker. You can find a detailed drawing of each part on some of the drawings that you'll have, and that'll help you to assemble each part in the right location. This is a typical arch that you can see on the computer monitor, and there's a couple real key things to remember as you put it together. These holes in the middle are the only thing that's different. The pattern for the splice is the same all the way up, and you can easily reverse the bar. But notice here how the hole is a little bit to the upper side of center line, and then the next bar up goes a little bit further above the center, until at the last one it's almost all the way to the upper side of the splice. It's very important that you put the splice plates and the rafters together watching these holes. If you're not getting all the holes lined up, then something is wrong and you need to flip a splice plate or a rafter bar. The codes A1, A2, A3, A4 are stamped in the top of the bar, but they aren't consistently at the bottom or the top end. So you'll have to figure it out by these holes when you put it together. It's just a quirk of the geometry making a dome. It's critical that you get that part right.
This she's like something else. I can just see it. Perfect.
Yep.
This shouldn't be hard, but
It shouldn't be, but shit happens.
my other truck then. Then I can sometimes take this, squeeze it together. And gotta go a certain way, gotta make sure of that.
How will they know which way is which?
Because if you put it in the wrong way, you line up the holes, the middle holes will not line up. But if you put it in the right way, you get those sides, that'll line up. And this is always towards the top.
Okay. Be just my luck.
And they could do all 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, then use the drip pins, tighten them all, and then just do these two last. That's probably what I would do.
They'll work that part out, I think.
Then we got one more. The top one, this can only go one way, right?
Yep.
Oh my gosh. Two of these are handy.
Yep.
These two in. Get it nice and tight, lined up perfect.
Yep.
Grab the small drip pins. Up. Alright, towards me. Alright, we gotta go over.
You be able to spread it enough to get the top crossbar in?
Yeah, we just want to get them started from loose. You don't want them tight.
Okay.
I just got to get them started. Alright, spread that out again. One more yet?
Yep.
Closer.
Yep, I'm started.
All right. One more.
Yeah, I just don't want to push it too far through that.
There you go.
Yep.
Just a matter of jerking it.
Yep. Let me get
Stuck on the top one.
there it is.
Okay.
Ooh, so go up. Right.
Yep.
But I held back.
There we go. There it is. Cross that.
Oh, I had it. Damn it. Oh, sorry.
Look at that.
Touch it. I won't be able to get with this.
That's good enough.
Inside. It's got a twist in it.
You want to make sure to caulk these metal parts together. So when you put the flat plate on top of the ring after you've insulated it and tightened all the bolts, set it in caulk and then caulk the seam all the way around. Then after you've put the cap on and drilled and put the screws, seal around the screw heads too. As you assemble the frame, you're going to want to pull dimensions from the toe of this hip bar to the toe of that one to control the width of the frame. The frame can flex and it will spread out and change the openings in the glass or make the frame not fit together. So this number down here is critical as you assemble the frame. You may need to anchor one side or the other so that you can pull this across with a come along or some kind of strap, something to pull it and hold it with tension. The weight will want to spread it, and you pull it back till you get the right number, and then you can add the next arch and keep going that as you anchor it. Remember to leave these bars off and these clips off so you can get access to drill these holes into the concrete. The bars around the edge are made to drop in this fashion. They will drop on over the clip, and that will allow you to put them in after you've anchored the frame. It shouldn't be too big of a problem. These bars will hold the shape of the frame as you get it all squared and anchored. After the bottom curb bar is in, you can use this number, which you'll find on the drawings as well, to check going that way. That's from center of bar to center of bar right off the shoulder. The first part to install is this flashing that lays down on the concrete. You want to be certain to put the black tape on the bottom of it to separate the aluminum from the concrete, or the concrete will erode the aluminum over time. This piece is welded, and it'll be stitch welded, so you're going to want to take caulk and run it all the way around the seam of that flashing to make sure it would hold water. The same at this end here, it's stitch welded. You want to caulk over that seam so that it will hold water. Then put the flashings in with the black tape underneath, and then elsewhere in the instruction manual it'll show you how to do the splice joint between these pieces. They're curved, but you want to make them be a watertight tray, and it'll take a little bit of thought to get your splice. I've dashed in the backer here, and then we always caulk over the top of it as well, sort of a band-aid joint on the outside, just to make sure it stays watertight. So the first step of all is put the flashing on the concrete after you've verified the diameter of the concrete ring. The rubber strip on top of the bar is often tapered like this, and that would be an 0057 glazing strip, and you'll want to go through it bar by bar and make sure that you put the right strips in. The ones on the pressure bars we did here in the factory, but you'll have to do these on site, and you'll need to take a look at all the details. So it's tapered, but this bar at the top gets the flat one. So make sure you take your time and look at the drawings and match A4 with the flat, A3 with the tapered. There's also a sheet that tells you which one to put in which bars. You'll want to put the flashing all the way around the ring as mentioned, and then when the frame is assembled, there's joints in the frame that should be sealed up in some way. And we have some plastic pieces that will help you to make it so they can carry water past them. Put caulk in this groove right here so that when you push this plastic piece down, it will carry water over the top. And then it'll sit in here and it'll be sealed. When you put the glass in, you'll seal this upper edge right to the glass. That way any water in the bar will go through here and carry it and drop it to the next one. Make sure it's bedded in a good sealant bed so that water can't go underneath the splice. You have a similar splice for down here for any condensation. I don't know if that's a worry, but it's easy enough to put these in a little dab of sealant to make sure that they can carry water as well. And that will happen at all of these joints for the frame, and that's something you want to do after you put the frame together. You'll go back and seal it, and then I also would recommend that you try to seal up in here. Try to make this bar be able to transfer some water to the glazing pocket here. It won't be easy. It's not really how the system is designed. Our system is a barrier system, not to let water in, but it's always a good idea to create a backup underneath it. So you'd want to build caulk and fill that groove up and then bring it up to here. Essentially, you're going to force the water to get high enough to flow into this bar and then go to the curb where it can be drained out. That would be the plan for all of these joints here. At the apex, you'll have a plate, you'll see in a different video, that's going to get caulked all the way around the ring, and then you'll want to bridge that ring into this rafter so that the water can come out of the ring and get into the rafter as well. Before you set the glass, put a bead of caulk on the top edge of the ring. That way when the glass is set, it'll smush into it and heel bead the glass all the way around it, so the water has no choice but to go out in the rafter. These plates are provided to give you something to caulk to. And again, like I mentioned before, the skylight is a barrier system, so that the glass, everything is going to be caulked to the top surface to make that barrier. So this surface is what we're trying to make be the watertight layer. And it's very critical that you do that. And what is going to be required is that these joints in between, you're going to have to caulk from the glass to the plate, and then over here, and then between the glass going up this way, about 50 millimeters. And that way you will be wet sealed glass to glass in the corner. And when your retainers come back, there will be something to caulk them to. So now you would want to take your wet seal for the retainer and wrap it around the end so that you can caulk this piece down to the glass. And that is going to hold true at both of those, and then also the horizontals. And there's a gap here so any water in this light can flow down and then go over and drain to the next one. So there's a whole system of gaps to let the water off the glass. And that's critical that you do these seals here. This is probably the single most important thing you have to caulk, is do these glass intersections and then caulk the retainers down to the glass. There's a detail of it on the drawings, and some further notes in the installation manual that will help you try to get a handle on how we do it. Take time, read it, maybe practice on a couple, make sure you're clear. If you need to, write me an email or call and we can try to make it crystal clear so it all gets done right. So at the cap at the top, you'll want to caulk the glass to the cap, and then the retainer will go to the glass itself. That's shown on the detail, but it's important to make this metal cap seal to the glass, and then the retainer, the pressure bar, down to the glass, so we're always maintaining the top of glass as the barrier. The panels would be considered the glass surface, so you would caulk these gaps as shown before. You'd wet seal your retainers to it, and you have a joint in the panel that also gets sealed. And then of course you've got the joint all the way around here that will help you caulk it to the base flashing. So you should have a barrier from the base flashing all the way to the top so that water can't get in the skylight. That's how we have built our skylights for 80 years. So that's where you want to try to follow everything that we're telling you.